Hello everyone, Namaste Robin. So today this in this class we'll again discuss the next part of organometallic compounds, and I'll be taking few more questions in this class. And like as we have done in the last class, we have just discussed questions and we have solved them based upon whatever we have studied for organometallic chemistry. Similar thing I'm going to do. I'm going to take few more questions from this topic, and we are going to cover this up, right? So, in the meantime, when others also join the class, let me just tell you guys about Unacademy Plus program. So, Unacademy Plus is a live platform where you can get like these classes are live classes who are seconds delay, but that delay and other things are not there on an Academy Plus, right? So you can ask your doubts over there. You will get a detailed explanation of the topic. There will be problem discussion over there, and you will also get recorded classes in case if you miss out any class, right? And there are different doubt clearing sessions after every few interval, like after every three classes, so that if you have any doubt you can ask them out in that particular uh, doubt clearing session. And I also have a WhatsApp group where you can discuss out your doubts. uh, Good morning, Amrit Raj. So sorry if I don't, if I'm not able to pronounce your names right. So I'm really sorry for that. But yeah, so this is all about your Unacademy Plus, and if you are planning to take subscription for that, you can take that using my referral code. So this N underscore Huda is my referral code. If you use this referral code, you will get 10% discount on the subscription fee. And I already have my courses over there which are already being taken. If you are planning to take it before this CSI net exam, you can take the subscription, and with that you will get access to watch all my previous lessons and all. So you will be able to um, watch all the classes. You will be able to see all the recordings. Okay, okay. And if you want to join it after the next CSIR net, so I'll be starting new batches after that, so you can join it at that particular time as well. Okay, so let's start the subject, our organometallic compounds, and let's see what we have in today's class. Okay, so let me just. Okay, so first of all, which books are okay, so first of all, why organometallic chemistry is so important? Because it is very easy to understand, one of the easiest topic in your inorganic chemistry. Then it takes less time to solve a question from organometallic chemistry. You just need to know few formula, and that will help you to solve that particular question. Also, it covers around 25 to 40 marks in your CSI net exam if it is asked in a full way. Okay, so it covers around 25 to 40 marks from part B and C both combined. And also from the research point of view, organometallic compound is very important. There are many research which are going on this particular topic. Now, books which you need to follow, yesterday I didn't mention about it, but yeah, these are few books, like three books which I will recommend you to follow for CSR net preparation. And these are like organometallic chemistry of transition metal by Robert H Crabtree. Generally people say it like organometallic by Crabtree. Then there is a book by BD Gupta, that also you can follow. And there is a book by Ajay Kumar, organometallic and bioinorganic chemistry by Ajay Kumar. So these are three books which you can follow. Any of these you can follow for organometallic compound. I have followed this BD Gupta, and later on I have studied this Ajay Kumar also. It's a very good book. Crabtree I have not followed that like in that intense way, but thoroughly I have read from Crabtree as well. But yeah, these books are good. Like Ajay Kumar is a good book. Now today in this class, questions will be taking from these topics like 18 electron rule, stability of the comp. So these are certain topics from where questions can be asked in your exam. Okay, so these are general topics like 18 electron rule is there, which tells you about the stability of complex, then isolability, then metal metal bonds, like how many metal metal bonds will be there. That is also one of the type of question which can be asked. Then your questions on weight rule, okay, just to find out is the your cluster given cluster is Clozo, Nido, or Acono, what kind of cluster is it? Then there are many miscellaneous problems as well, okay, based upon these things only, just they will ask in some other way. Reaction mechanism based problems are also there, in which you will have to tell that what kind of reaction mechanism is going on, whether it is like associative addition, dissociative elimination. So these kind of reactions, like 1 migratory insertion, 1 2 migratory insertion. So you should be aware about these reaction mechanisms as well. And at the end, you have NMR based problems on organometallic compounds. So these are certain type of question which are asked in from this particular topic. Okay, so this is a table. Okay, you can take a screenshot of this. This table tells you about the electron count in two different methods. There are two methods. One is neutral atom method, and the other one is your like oxidation state method. Okay, so like different ligands are written over here, and their these are electron counts which are given to you. Okay, so how much electron you will count. So you can take a screenshot of that if you want, and like this will help you to remember that which ligand will give how much electron in which condition. Like if you just look upon over here, so halogen, like halogen, if it is attached to the metal, this one, the metal halogen bond, it gives you one electron, okay, in the neutral atom method. But when it forms a bridge, okay, in the bridging form, it gives you three electron. Okay, so this is something you need to remember, you need to know what will be the electron count in the different methods. Okay, so let's take this question. Over here it says that the complex that does not obey 18 electron rule. So which of these complexes does not obey 18 electron rule? Just try to do this. The first one, it's given that you have eta 5 Cp, okay. C5H5 means Cp, means cyclopentadienyl. So I'll just write down it as eta 5 Cp. Then you have ruthenium, Cl, Co, and PPH3. Okay, so this is the complex given to you. So just try to do this. Yeah, yes, Bharti. These are some examples. Okay, just try to do. So what about this eta 5 Cp? You will get 5 electrons from here. You can see that from the table also, that like eta 5 cyclopentadienyl. Here it is. Okay, so here it is. So it gives you 5 electron. Eta 5, wherever you get a hapticity kind of thing, it's if it is like eta 3 Cp, so you have to take 3 electron counts. Okay. Now ruthenium, it lies in which group? Ruthenium, which group element it is? Just you just have to look upon the periodic table for this particular thing. Okay, so you should know about the periodic table, and you should know that which element lies in which group. Okay, so ruthenium lies in the iron group. Ruthenium, iron, and your osmium, right? So all these three, yeah, so all these three lie in that group. So you will be having 8 electron from that, because iron is your 26 atomic number 26, and it's 4s2 3d6. Okay, that means 8 electrons. So ruthenium will also give you 8 electron. Chlorine will give you 1 electron, 2 electron from this CO ligand, and 1 electron from this PPH3. If you just add them up, so 8 plus 2 is, sorry, 2 electrons from PPH3. Okay, so 2 electrons from this PPH3. So 8 plus 2 is 10, plus 3 is 13, plus 5 is 18. So it's a 18 electron rule. Okay, so yeah, so you can go for the other options as well. So just look upon option number D over here. So osmium over here is given. So it's given osmium. Then you have N. Okay, N is the nitrogen. Br2, PME3. Okay, and then you have NME2 minus. Okay, this is what is given to you. So over here, if you look, osmium will give you 8 electron because it's in the same group as the ruthenium is. Nitrogen gives you 3 electron. Okay, nitrogen is a 3 electron donor. Bromine is 1 electron donor, so 2 electrons will come from bromine. PME3 will again, it's similar to PPH3, so it will again give you 2 electrons, just like your PPH3 was giving you. And NME2, okay, NME2 is a ligand, it will give you how many electrons you'll get from NME2? So yeah, one negative charge is also there, right? So so you will be getting 2 electrons from here. Okay, NME2, NME2 will give you 2 electrons and plus 1 from the negative charge. So overall you will be having 15 plus 3, so it's a 18 electron species. Okay, so again it's a 18 electron species. We'll just check for NME2 how much electron does it gives you. So PR3 gives you 3 electron if it is in bridging form, and it's not given for NME. Yeah, it's given, right? Nr2, it gives you just 1 electron. So metal with Nr2 gives you just 1 electron. We have to take just 1 electron for that. Okay, so NME2 will give you just 1 electron, and now it's not a 18 electron species, it's a 17 electron species. Alright, so your option number 4 is a 17 electron species, and that's your correct option, where it is said that does not obey 18 electron rule. So option D is the correct option for this. Alright, okay, so you can check for the other options also. Option B and C I'm leaving for you guys. Try to do that and check whether they are 18 electrons or not. Okay, let's go to the next one. Over here it says that the oxidation state of molybdenum in this, that is eta 7 troponium, okay, troponium, and then you have molybdenum and CO3. Okay, this is the complex, and they have asked that what is the oxidation state of this. Okay, just try to do this one. So how do we do that? Okay, so let's say that, oh, how much this. Okay, so troponium, eta 7 troponium will give you 7 electrons. Then molybdenum, if it is in the zero oxidation state, let's say molybdenum is in X oxidation state. Okay, let's say it is in plus X, because the oxidation state always remains in, okay, let it be like, let's say it is in zero oxidation state, okay, for now. So molybdenum is in zero oxidation state, means how many electrons does it will give you? So zero oxidation state means, over here this molybdenum, because we are just taking which method, we have taken neutral atom method, so we will be just taking it as, okay, fine. So molybdenum will give you, it's in the chromium series, right? So chromium series means you will be having 6 electrons in the molybdenum, and then from each CO you will get 2 electrons each. So that will give you like 2 into 3. Okay, so that's what you will get. So if you add them up, you will get 7 plus 6 plus 6. Overall, you will get 7 plus 6, 13, plus 6 is 19 electrons. So you get 19 electrons from here. But what you need one less electron, right? You need an electron lesser than that. You don't need 19 electron. So how you can make that one electron less? By adding a positive charge over here. Or if molybdenum, instead of giving 6 electron, if it would have given 5 electrons only, in that case we would have got 18 electron, right? So that means molybdenum should have given 1 electron less from the required one. So when it will give you 1 electron less, when molybdenum will have a charge, and what charge it should have? It should have a positive charge. If its electrons are reduced from the usual one, that means what? That means it has a positive charge. So that means molybdenum, instead of having plus 6 charge, it should have plus 5 charge. So that's how your option number B becomes your correct choice for this question. Okay. Alright. So let's talk about this question over here. It's also a good one. It says that the molecule, this is the molecule given to you. It's like OC5 means nothing but CO. Okay. Then it is attached to metal. Then double bond OCH3, then C6H5. Okay, this is the complex given to you, and they have asked, this obeys 18 electron rule. Okay, it's given that it obeys 18 electron rule. It's already given. So they are asking that which metal will be here which will satisfy this particular condition, which will satisfy this 18 electron rule condition. So how we will do that? First of all, just use to find out total valence electron. So since it's a carbonyl ligand, 5 carbonyl ligands, so 2 into 5. Metal we don't know, so let's take it as X. Since it is forming double bond with this C, so that's why it will give you 2 electrons. Okay, so this C will give you 2 electrons. Okay, OCH3 is a ligand again, so this particular OCH3 will give you 1 electron, and this C6H5 will again give you 1 electron. So if you add all these, you will get like 10 plus x plus 2 plus 1 plus 1. Okay, so that means overall you will get 14. How much you will get? You will get 14 plus x. That means how much this x should be? This x should be equal to 4 more, right? It should be equal to uh, 1 minute. Huh? Yeah, it should be 4 more. So where you will get 4 more electrons? That means I think we have done it in a wrong way. 1 minute. How much we have taken? We have done it in this way that we have 2 into 5 from this CO. Okay, then metal we don't have. Let's say it's X. 2 we get from here. This OCH3 is attached to this carbon actually. Okay, this OCH3 and this are a whole one like one single ligand. Okay, so it's given in that way, and then C6H5 will give you 1. So that means you have just 1 that will come from here. Okay, so that means you have 13 plus x. So x should be equal to 5, right? You should get 5 electrons from x. That means your metal should be a 5 electron donor. You have to look upon the options, that which option will give you 5 electrons. So just look upon there. So what will be the answer over here? Just let me know. Tell me which options will give you 5 electrons. You need 5 electrons. Just look that which options will give you 5 electron. Which one it will be? I think vanadium complexes will give you 5 electron. है ना? So vanadium complexes will give you 5 electrons. So option number C, because it's a like D3 complex, so that will give you 5 electron. So option C will be your correct option for this question. Okay, fine. Let's go to the next one. Okay, this question over here says that in the cluster, this is the cluster given to you, CO whole thrice, then CH, and then CO9. Okay, this is the complex given to you. Obeying 18 electron, the number of metal-metal bond and the bridging ligands respectively are. Okay, so they have asked what is the number of metal-metal bond and what is the number of bridging ligands over here. Okay, so we'll try to do this one. First of all, how to find out bridging electron? For that, you need to find out total valence electrons. Okay, so how we do that? So for Cu, for cobalt, how much electron we'll get? Good morning, Chem Challengers. Good morning. So for cobalt in the neutral atom method, you will get like cobalt has electronic configuration of 4s2 3d7. So we will get 9 electrons from cobalt. So 9 into 3 because we have 3 cobalt over here. Plus CH unit. See how to find out the number of donating electron from CH unit, since you know that CH4 gives you 4 electrons. Sorry, CH4 is not an electron donor. CH3 methyl is a ligand and it gives you 3 electron. Similarly, CH2 will give you 2 electron and CH will give you 3 electrons. Okay, so you reduce the number of hydrogen, number of electron donor ability will increase. Okay, okay, Rajiv, nice to see you. Hi. Okay, so CH will give you 3 electrons. So let's write down 3 over here. Then CO, this is carbonyl ligands. Okay, so each carbonyl ligand will give you 2 electrons. So 9 into 2. Overall, what is the total valence electron that you will get? So 27 plus 3 and plus 18. So you will get overall 48 electrons. Okay, so 48 electrons you will get. Sorry, 48 is the total valence electron. Now I have explained it in the last class also that we take it as A. Okay, just consider this value as A. Now what you have to do, you have to calculate B. B is what? That is 18 into N minus A. That means 18 into, what is N? N is the number of metal over here. So 3 minus A means 48. So 18 into 3 is 54 minus 48. So that will give you 6. And this B by 2 gives you number of metal bonds. Okay, so that will be B by 2. That means 6 by 2, and that will give you 3. So that means how many metal bonds you got? You got 3 metal bonds. नो प्रियंका, एक नहीं होगा. देखो ऐसे देखना है जैसे CH3 ग्रुप से CH3, हाँ सॉरी, हाँ CH3 एक इलेक्ट्रॉन होगा, सॉरी, CH3 will give you 1 electron. Yeah, good, Priyanka. Okay, so this will be 1 electron donor. Okay, so number of metal bonds we got 3. Now that means if you have 3 CO ligands, so how they will be attached? They will be attached by this 3 metal bonds you got. Okay, now you have to make CO9, that means 9 carbonyl ligands. So let me just divide it equally. So I'm just giving 3 carbonyl ligands to each metal center. Okay, I'm just drawing the probable structure which could be the possible structure. Okay, so this is how I have distributed them. Now since this CH unit is a bridging, it will act as a bridging ligand over here, and it has a hapticity of 3. That means it can give 3 electron. So we can write it in the center, and we can write it like CH, and that is attached to all these 3. So 3 bonds are made by this CH unit. Okay, so now just check that whether all these like individually all these metal are 18 electron rule, following 18 electron rule or not. So if I just talk about this particular CO ligand, so it will have 9 electrons of its own, then 2 plus 2 plus 2, 6 electron comes from these carbonyl ligand, and 1 2 and 3, these 3 electrons are coming from these 3 bonds. One is metal bond, one is metal CH bond, and again one metal bond. So 3 electrons are coming from there. 9 plus 3 is 12, plus 6 is 18. So it's 18, it is following 18 electron rule. That means this structure which we have made is a stable structure, and this is the probable structure of this complex. Now you have to just answer the question that how many, like it was asked, right, that the number of metal bonds over here. So how many metal bonds we got? We got 3 metal bonds, and the bridging ligand over here is CH unit. So answer is option number A. So bridging ligand is 1 CH unit, and there are 3 metal bonds over here. So that's how you do this question, and that will be the correct answer for this. Okay, understood everyone? All right, so we'll go for the next one then. Okay, now this question is from your NMR part of your uh, of the organometallic compounds. Okay, it's given that a complex is given to you, that is HMCO5. Okay, this is the complex given to you, and there is one more complex, it's eta 5 C5H5. Okay, and C5H5, then you have M dash, and then you have CO3 whole twice. Okay, whole twice. Now they have given that they both obey 18 electron rule. Okay, both of them. Yeah, what happened, Amrita? Acha, 18 electron rule. See how it is done. 9 electrons you get from this complex over here. Okay, 9 electrons you got from this complex, and sorry, with the metal center. So 9 I got it from CO. Okay, CO metal, it gave me 9. 6 I got from the 3 CO ligands, because each CO ligand will give me 2 electrons, so 2 into 3 will give you 6. And these 3 I got from the bonds. Okay, individually, or if you look upon a particular metal center over here, so since it is forming 3 bonds, like 1 bond, 2 bond and 3 bond, each bond contributes to 1 electron to this metal and 1 electron to the other side. Okay, so each bond contributes towards 1 electron. So since we have 1 2 and 3 bonds, one bond like 2 metal bond and one is metal CH bond, So each bond contributes one electron towards single metal. So that's how we got 3. So 9 plus 6 plus 3 will give you 18, right? 9 plus 3 is 12 plus 6 is 18. Got it? Bharti? Understood? Okay, let's go for the next one then. Yeah, so we were talking about this one. Over here, these two complexes are given to you. They obey 18 electron rule. You have to identify M and M dash and their proton NMR chemical shift relative to TMS. TMS is tetramethylsilane. Okay. So first of all, you can easily find out using 18 electron rule. Let's do for the first complex. Uh, Over here, this hydrogen is a 1 electron donor, so we'll write down 1. Metal, we don't know, so let's write it down X. And each CO will give you 2 electrons, so 2 into 5. Okay, so that's from where you will get for the CO. So 10 plus 1 is 11, so you get 11 plus X. Means in order to follow 18 electron rule, X value should have been 7, right? So X should be 7 in order to make the complex follow 18 electron rule. It means M is something having 7 valence electrons. Now 7 valence electron means 4s2 3d5. This should be the configuration. That means what is the metal over here? So metal can be manganese. Okay, metal has to be manganese. So that's what we predicted. So that means M, we just got our M. I'll just write down over here at the corner. So M is nothing but manganese. Understood? Coming back to the question and looking at option number 2, if I come over here, now in the question it's not given how many metal metal bonds are there. Okay, if it is not given, then it will be difficult for you to predict, but for now I'll just consider that there is just one metal metal bond. Okay, I'll just consider that there is one metal metal bond. So based upon that, I'll solve this. So eta 5 C5H5 will give you 5 electrons. M dash is a metal. Let's say it gives X electron. Each CO will give you 2 electrons. So 2 into 3. Okay, so that's what you will get. So this will be like 5 plus X plus 2 into 3 is 6. And 1 we will get from the metal metal bond, because it's given it's twice, right? So there will be two complexes of the same kind. I'm just taking the first one of the complex. I'm just finding out that whether that is following 18 electron rule or not. Okay, so one I have taken from metal metal bond. I have just considered that there is one metal metal bond. All right, so we'll check the other possibilities also, but for now I have just taken one as the metal metal bond. So 2 into 3 is 6 plus 1 is 7. So it will be like 7 plus 5 is 12. So X plus 12 means X has to be 6. Okay, X has to be 6 means it should have electronic configuration of 4s2 3d4. So that is what, or sorry, it should be it like it, this one. Okay, so this can be this. So this is nothing but chromium. Okay, so this can be your chromium. So that's how I just predicted that M dash is your chromium. Okay, so I just got both of them, M and M dash. Now there could be one more possibility. And what is that possibility? That there is no metal metal bond. Let's say there is no metal metal bond. In that case, what will happen? Let's say there is no metal metal bond. Okay, so if let's say we don't have any metal metal bond in the complex, so in that case we will be having 5 plus X plus 2 into 3 and plus 0. We will be taking 0 metal metal bond over here. Okay, so I will be having like 5 plus X plus 2 into 3 is 6 and plus 0. So X plus 11, again I got X plus 11 over here. Now that means X has to be 7. That means like the M dash has to be like, it can be manganese also. Okay, so first option manganese, second option can be chromium or manganese, anything. Okay, so if you just look upon the options, in the option you will see that there is just one option where it is like first option is manganese, like M is manganese and M dash is given as chromium. So manganese is not the possible, like it's based upon the options we can say that answer will be option number A. Okay, now coming to the chemical shift values, that what about the chemical shift value? Why this chemical shift value is minus 7.5 and why it is 4.10? So for that, you just have to look upon the metal structure a little bit. So I'm just taking this complex. First of all, it has hydrogen attached to metal, and then you have CO ligand. Okay, so you have CO ligand. Other CO I'm not drawing. You have 5 CO, but I'm just drawing one of them. Now you all might have studied about the synergistic effect. Okay, synergistic effect. What does that effect tells you? It tells you that in the metal, like between the metal d orbital and between the CO anti-bonding orbitals, there is sharing of mutual sharing of electrons. When CO needs electron, metal gives its electron density towards that, and if if metal has an electron, then CO gives it to that. Okay, if you look upon the oxidation state of this metal over here, so that will be +1. Okay, so metal is in +1 oxidation state over here, because CO is a neutral ligand. Hydride ligand will give you -1. So overall you will get +1. So over here, if you see, the metal is it's quite electron rich, right? So metal over here, okay, metal is electron rich. And since the metal is electron rich, so there will be like synergistic effect happening, and electrons will flow from metal to CO side. Okay, from metal towards this CO side, electrons will flow in this direction. And if this happens, what will happen, that metal will electrons will go in anti-bonding orbitals of CO. And if that happens, your bond order of CO will decrease, your carbonyl frequency will decrease, your carbonyl bond strength will decrease, and carbonyl bond length will increase. So these things will happen over here. But what about this hydrogen? Okay, so what about this particular hydrogen? So since I just told you that like this particular metal is a positive, like it has a positive charge and it's electron rich, so that makes this proton very much shielded. Okay, so this proton becomes shielded. Okay, so this proton or this hydrogen is shielded in this case, quite shielded. And due to this shielding of this hydrogen, this will give you an upfield chemical shift. Okay, so upfield chemical shift. So due to that upfield chemical shift, we are getting this value around -7.5. Okay, so upfield chemical shift means chemical shift value will be very much less, and that's the value you are getting around 7.5. Talking about the second complex over there, your like NMR will be given by, like, proton NMR active region is nothing but your this eta 5C5H5, means this cyclopentadienyl ligand. So if I just make it, so it will look something like this. So this is your eta 5, and you have metal, you have CO attached to that. Okay, so since these are the protons which are attached over here, these protons are not directly attached on the metal, so they will not get affected by the metal electron density or anything. These protons are on cyclopentadienyl ligand, and their chemical shift value lies between like 4 to 5 uh, like 4 to 5 ppm. So that's why your correct answer is option number A, based upon 18 electron rule and based upon the NMR values given to you. Okay, clear? So this is how NMR is being mixed with your like with all these terms. Okay, with the 18 electron rule, with your organometallic compound. So you should be aware about, and you should be good enough to solve these questions. Okay, let's talk about this one. It says that the hapticities of X and Y of the arene moieties in the diamagnetic complex. So it's given that the complex is diamagnetic, and they have asked that what is the hapticity over here. So diamagnetic complex they have given, and the complex is this, that is eta X C6H6, and you have ruthenium, and then you have eta Y C6H6. Okay, so that's what they have given. Now they are asking that what is the hapticity over here. So ruthenium we have done, it belongs to the iron family. So let's say that X is the hapticity plus ruthenium will give you how much? It will give you 8 electrons and plus Y. Okay, so that's what you will get. And in order to make a diamagnetic complex, this particular, now see again the same thing they have asked in a different language. Language of question is different. They have asked that it should give a diamagnetic complex. What does that diamagnetic complex means? Diamagnetic complex, that means if you draw the MOT, that means molecular orbital diagram of these complexes, you will see that a complex becomes diamagnetic when it follows 18 electron rule. Okay, so if it follows 18 electron rule, it becomes diamagnetic. All the electrons remain paired over there. So they have just asked that which what will be the hapticity of these arene moieties such that this complex becomes 18, such that this complex follows 18 electron rule. So instead of asking about 18 electron rule, they have given in the form of diamagnetic. Okay, fine. So it should be equal to 18. That's what we have. We should take it. Okay, so it should be equal to 18 electrons. So it should be 18 electron species. So what should be the value of x plus y? That should be 18 minus 8, and x plus y will give you 10. So that means if you add these values of x and y, you should get 10. If you look in the options, option A, we have 6 plus 6, it's giving us 12. In option B, we have 4 plus 4, it is giving us 8. In option C, yeah, very good. In option C, we have 4 plus 6, it's giving us 10. In option D, 6 plus 2 is giving us 8. So it's very simple and very straightforward that option number C is the correct option. Very good, Priyanka. Okay, so that's how this question has to be done. Okay, let's go for this one then. Okay, I think this should be this would be the last question of this class. Okay, over here it says that on reducing this complex, the complex is like Fe3CO12. Okay, this is the complex with excess of sodium. If I take sodium in excess, so a carbonylate ion is formed. Okay, so a carbonylate ion is formed. The iron is isoelectronic with. So I have a carbonylate ion. So I don't know what ion it is, but yeah, let's say this is the ion which is formed. Ion A is formed. So they have asked that iron is isoelectronic with. Okay, so sorry, it should not be iron, it should be ion. Okay, so the ion which is formed is isoelectronic with. So before doing any kind of question, whenever you have some reaction or anything, you just need to know first of all that how many metal-metal bonds will be there. So find out metal-metal bonds in this in this complex. So use total valence electrons method. So you will be having 3 into 8, that will come from this iron atom, and plus 2 into 12, that will come from these carbonyl ligands. So when you solve this, 24 plus 24, so you will get 48, and this is nothing but A. Okay, so B we have to calculate, that is 18 into n minus A, and that will be 18 into 3 minus 48, so that will be 54 minus 48, that is going to give you 6, and B by 2 gives you metal-metal bonds, so 6 by 2 gives you 3, so I got 3 metal-metal bond over here in this complex. Okay, so if I make the probable structure of this complex, so it will look something like this. Fe will be attached to Fe and will be attached to Fe like this. Okay, so 3 metal-metal bonds I have, and now I will just give these CO ligands equally to all these metal centers. Okay, equally I will just distribute to all of them. So I was having 12 CO ligands, I have just distributed them equally. Now, if you react it with excess of sodium, what will happen? See, whenever a reaction happens, remember this point, that whenever you have a reaction with some organometallic cluster having metal-metal bond, so always your metal-metal bonds will break. Yeah, so always your metal-metal bonds will break, and that is going to give you the required complex. Okay, so that means what I'm going to get over here is nothing but this, that is Fe. How much CO I have? 1 2 3 4, so 4 CO, so CO4, and 2 minus, right, because two bonds have been broken, so 2 minus. And to neutralize that 2 minus charge, I can write it in this way also, that I can just remove this 2 minus and I can write down Na2 FeCO4. Okay, so that's what I got. Now you just need to know that the ion which is formed, this is the like if I just talk about the ion, so what is the ion? Ion is nothing but FeCO4, that's the ion. Okay, So you have to see that which of these complexes are isoelectronic with that. Okay, so FeCO4 2 minus. Just look upon the options. So just if I just talk about this iron complex, so yeah, so iron is having 8 electrons. Okay, so it's a 18 electron species. Now go with the options. Which options are following 18 electron rule? So if you look upon option number A, so manganese complex over here, it will also follow 18 electron rule, right? You will get 7 electron from manganese, then 10 electron from this CO, and plus 1 due to this negative charge. So you'll get 18 electron. Option 2 will also follow 18 electron because you will have 10 from nickel and plus 8 from this CO. So you will have 18 electron. Option C and D won't follow 18 electron, I guess. Option C will follow 16 electron, and option D will follow like it will be 5 from vanadium, and it will be like 12 from this CO ligand and plus 1. So this will also follow 18 electron. So now either option A can be your correct one, B or D. Okay, C cannot be your answer because this is not the stable one, because this ion is following 18 electron rule. So that these should also follow 18 electron rule. Now you have to look upon, they have said that which of these is isoelectronic. Isoelectronic means the one which have similar number of electrons. So if you just go with the electrons, so our answer should be A, B and D all, because all of them are isoelectronic. All of them are actually following 18 electron rule. So answer should be A, B and D all. But the question over here is not complete. It should be isoelectronic and isostructural. Means the number of electrons and the structure should also be same. Okay, so whenever it is not given, let's say if in the exam also they just forget to ask you about isostructural, don't worry about it. And if you have different options over there which all are having similar number of electrons, then go with that option which has similar structure also. Now if you look option 1, A, B and D, option A will have a TBP kind of structure, trigonal bipyramidal, because this CO is, you have 5 ligands, you have to attach them. So it will be something like TBP kind of structure. Option B will have a structure of tetrahedral, and option D will have a octahedral structure based upon the ligand number of ligands I'm just telling. Okay, now the ion which is given to you also have 4 ligands, 4 CO attached, so it will also have a tetrahedral kind of structure. So that means what, that this particular ion is isostructural with which one, with option number B. So correct answer for this question should be option number B. Okay, so once again I'm just repeating over here, we were asked to find out isoelectronic species. Now in the options given over here, 18 electrons, like our ion is also following 18 electron, and our option A, B and D, all of them are also following 18 electron rule. So we have a choice, that we have to make a choice that among all these three which is the correct answer. So now you have to look that which option has a similar structure as the ion given to you. So the ion given to you was having 4 CO attached to that. That means it will have a tetrahedral kind of arrangement. And if you look in the options, so nickel complex over here has a 4 cobalt attached to that, sorry, 4 carbonyl ligand attached to that, and that also has similar structure, same number of electrons. So that will be your correct structure and the correct answer for this question. So in this way you have to answer questions, and I have taken 2 classes on this. आयन आइसोइलेक्ट्रॉनिक होना चाहिए, हाँ तो 2 माइनस, दैट्स व्हाट आई सेड। आइसो इलेक्ट्रॉनिक का मतलब क्या, कि इलेक्ट्रॉन, नंबर ऑफ इलेक्ट्रॉन्स सेम होने चाहिए दोनों में, राइट प्रियंका? सो नंबर ऑफ इलेक्ट्रॉन सेम ही तो है। देखो वैलेंस इलेक्ट्रॉन, इफ यू जस्ट लुक अपॉन, अच्छा अगर तुम सिर्फ चार्ज को लेकर के करो कि देखो इसमें अगर तुम देखो ये जो आयन फॉर्म हुआ है FeCO4 2 माइनस, ये भी 18 इलेक्ट्रॉन स्पीशीज है। हाँ निकल न्यूट्रल है, दैट इज करेक्ट। देखो यहाँ क्या बोला है कि यहाँ जो आयन जो तुम्हें मिला वो आइसो इलेक्ट्रॉनिक इनमें से किस कॉम्प्लेक्स से, ये पूछा गया। आइसो इलेक्ट्रॉनिक का मतलब क्या होता है कि किस इलेक्ट्रॉनिक, आइसो इलेक्ट्रॉनिक मीन सेम नंबर ऑफ इलेक्ट्रॉन्स। सो तुम्हें चेक करना था कि किस में सेम नंबर ऑफ इलेक्ट्रॉन्स होंगे, ठीक है। अब देखो इस क्वेश्चन को कई तरीके से आंसर कर सकते हैं। अगर सिर्फ यहाँ बोला गया है आइसो इलेक्ट्रॉनिक की बात की गई है, तो आंसर मैंने क्या बोला कि आंसर तीनों होंगे, ऑप्शन ए भी होगा, ऑप्शन बी भी होगा और ऑप्शन डी भी होगा, क्योंकि तीनों में 18 इलेक्ट्रॉन रूल। ठीक है, तीनों में 18 इलेक्ट्रॉन्स है, क्योंकि कॉम्प्लेक्स भी 18 इलेक्ट्रॉन रूल फॉलो कर रहा है और ये तीनों भी 18 इलेक्ट्रॉन रूल फॉलो कर रहे हैं। ठीक है। हाँ, अगर ऐसा होता है कि इनमें से आयरन की ऑक्सीडेशन स्टेट यहाँ क्या है, -2, अगर इन ऑप्शंस में ऐसा कोई कॉम्प्लेक्स दिखता जहां पर वो 18 इलेक्ट्रॉन रूल भी फॉलो कर रहा है और वहां मेटल की ऑक्सीडेशन स्टेट भी -2 होती, तो वो सही हो जाता। बट सिंस ऐसा भी कोई ऑप्शन नहीं है, मैंगनीज यहाँ -1 ऑक्सीडेशन स्टेट में, निकल 0 ऑक्सीडेशन स्टेट में, वेनेडियम -1 ऑक्सीडेशन स्टेट में, यानी कि ऐसा भी कोई स्पीशीज नहीं मिल रहा है जहाँ पे -2 ऑक्सीडेशन स्टेट में। तो अब स्ट्रक्चर पे जाएंगे, यानी कि अब लिगेंड देखेंगे कि लिगेंड किस में सेम है। ठीक है, सो वो किस में मिला, ऑप्शन नंबर बी में। ठीक है। सो हमने 2 क्लास ली है अभी तक ऑर्गेनोमेटेलिक कंपाउंड्स पे। आई होप कि लाइक क्लासेस हेल्पफुल हैं, और क्लासेस आई विल ट्राई टू टेक, एंड आई विल जस्ट सजेस्ट जो भी बच्चे इस क्लास को रिकॉर्डिंग देख रहे हैं, सो प्लीज़ लाइव क्लास अटेंड करने में ज़्यादा फ़ायदा होता है, क्योंकि तब आप क्वेश्चन डिस्कस कर सकते हो, जो मैं बता रहा हूँ उसी टाइम पे आप पूछ सकते हो। सो ये कुछ बेनिफिट है, अगर आप चाहते हो आप अटेंड कर सकते हो लाइव क्लास, दैट विल बी मच बेटर, है ना। सो नेक्स्ट मेरी क्लास आज ही है 12 नून पे। ठीक है, 1 घंटे बाद मेरी क्लास स्टार्ट होगी, एंड दैट विल बी ऑन क्वांटम केमिस्ट्री। ठीक है, सो क्वांटम केमिस्ट्री के क्वेश्चंस लेंगे वहाँ पर और वी विल डिस्कस इट ओवर देयर। ठीक है, सो आई एम हैविंग क्लासेस लाइक यूट्यूब पे, मेरी क्लासेस जो चल रही हैं वो हैं ट्यूसडे को। ओके, ट्यूसडे को क्लासेस रहती हैं 2 बजे से स्टार्ट, उसके बाद सैटरडे को भी 2 बजे से ही क्लासेस हैं, और संडे को मेरी 2 क्लासेस हैं, एक है सुबह 10 बजे से और एक है 12 बजे से। ठीक है, सो एक सुबह 10 बजे से और एक 12 बजे से। सो लाइक वीकली 4 क्लासेस है मेरी अभी नवंबर तक। दिसंबर में आई ट्राई टू टेक मोर, ताकि ज़्यादा बेनिफिट मिले सभी बच्चों को। ठीक है, so I'll just end up over here. You can subscribe to this channel so that whenever I come live or any other educator who is teaching comes live, you get notification regarding that. And that's all guys. Okay, so thank you so much for being here. Thank you so much for attending the class live, and see you guys in the next class.